Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our right rectangle by function, our mid rectangle by function, and our trapezoidal by function. This video assumes that you have already watched the earlier videos in the series focusing on numerical demos, particularly the one that helps us set up this project and start with triaging our main, as well as the video that focused on the left rectangle by function. What we're going to do in this video is we're going to focus on how you can quickly extend the left rectangle by function because we have written it correctly, and simply modify the function, or excuse me, modify the equation that is used to calculate the area under each segment in our curve. So without further ado, I'm going to look once again at my left rectangle by function. And essentially what I'm going to do is I'm going to recalculate our area current. Now, to begin with, we simply want to go ahead and copy and paste the entire function, left rectangle by function, and we're going to overwrite what we had stubbed in earlier with the right rectangle by function. And you'll notice that really the only things that need to be changed are any references to left. So for instance, here we can convert that print statement back to right rectangle by function. We've done all of the error checking. As a matter of fact, none of that really changes. And also our output file to right rectangle.csv. But then because we have taken the time in the earlier video to go ahead and create these temporary variables for x left and x right, there's very little that has to be done here. The significant change is only in that what we are using for the height of the rectangle. So in the earlier video, we used the left side of the rectangle to calculate the y, or the height. And particularly here, I noticed that I have a minor typo in my comments so that it's actually supposed to be the f of x left. I'll make sure and change that up here as well. But for the right side, then, we simply want to use the right side of the rectangle to calculate the area for that particular segment. And so in this case, we'll have y equals to f of x underscore right. And at that point, since you were using a temporary variable for area current, you've got really no changes to be made with the rest of the function. Also note that if you look at the comments file that I provided for your right rectangle.csv, it also asks that you store both n current, but also x left and x right, as well as area current. So once again, no real changes have to be made since we spent our time on the first function. So just to be sure, we'll go ahead and build it. We can come out now to our command window, and what we can do is we can use the parametric mode for our two examples. So I'm going to use my left rectangle by function. I'm going to compare my, or rather not compare, I'm going to use my sine function from 0 to 1.57. And instead of for 101 intervals, I'm just going to focus on 11. I'm going to go ahead and run this, and you'll see that that results in an area of 0.918650. And I'm going to repeat this now, except the difference being is I'm going to use my right rectangle. And you'll notice that it also is not accurate. In other words, it doesn't return 1, but it's essentially estimating high. Okay, so we have a low estimation for our left rectangle, and we spoke about that earlier in the video, where one source of that is in that the approximation for that first segment for the sine function is actually going to have a y equals to f of x of 0. Well, with the right rectangle, we would have essentially overestimated because that first segment would be using a larger area than is actually enclosed by our sine function. Now, to continue with our testing, what we want to do is we want to look at the left rectangle and we want to jump up the number of values or the number of data points in to back to 101. I'm not changing anything else about the function that we're using. And you'll notice that I'm now up to 0.9913. I'd likewise like to do the same thing for the right rectangle. I'd like to use 101 segments. And you'll notice that I am getting closer to my value of 1. In this case, my right rectangle estimates it at 1.007033. I'm going to continue to do this. I'm going to use 1,001 segments. And you'll notice that I'm yet a little closer to 1 using my left rectangle. And then also, if I use my right rectangle and I bump it up to 1,001, I'm getting closer. Okay, so essentially what's happening is my left rectangle is approaching from the left side, where my right rectangle is approaching from the right side. So essentially, you'll see that these two are ultimately going to converge to 1. Now, what we'd like to do is we'd like to go ahead and set up our additional functions, particularly, or rather our additional methods, particularly our trapezoidal and our mid rectangle. Well, once again, what we want to do is we want to take a look at the Wikipedia article for a quick reminder of how we actually use the rectangle rule and the trapezoidal rule. For the rectangle rule, I started off using the left side of the rectangle, which we said was going to lead to some errors in estimation. However, no approach is going to be perfect because essentially what we're doing is we're utilizing a linear value to, a linear approximation to approximate the area under a curve that is not linear. In other words, the only way you can approximate the only function for which that a rectangle rule would be accurate is actually a step function, because it would essentially, or rather a rectangular step function square wave, because essentially it would encompass a rectangle. Now, for this particular example, they used the midpoint. So that's our starting place for our example. And if you notice that essentially what they're doing is they are averaging the x left and the x right. So we are going to do the same for our midpoint example. So what we want to do now is we want to copy our function, and we want to paste it into our mid rectangle or midpoint, if you would. And everywhere we overwrote that, we have to make some quick modifications. So we're going to call this one mid rectangle, mid rectangle. And then what we want to do now is we want to consider adopting an additional temporary variable. And we're going to call this one x mid. So we're going to have double x mid, and essentially the x mid is just simply going to be the average of your x left and your x right. So in this case, it's going to be 0.5 times our x left plus our x right. And at that point, then what we want to do is we simply want to pass that x mid to our f of x and utilize that now to calculate our area current. Well, if you look at the instructions, you'll notice that for my mid rectangle.csv, I've asked that we sneak in one additional column. So we'll notice here that we have our end current, we have a left, a mid, a right, and then the area current. Once again, because we spent our time with our first function, this is not terribly difficult. In other words, all we have to do is add another %f in our fprintf, as well as simply adding our additional variables sandwiched in between our x left, our x mid, and our x right. And hopefully you're starting to see that this CSV file is meant to be nothing else other than a check for you that your functions are working correctly. Now we are going to use it when it comes to our compare switch later so we can compare the values for each one of our methods. At this point, we can go ahead and compile it. And assuming that we didn't miss any obvious things in our conversion from our right to our mid, in other words, things like our file name and any of our comments, the most important thing is simply this calculation for our X mid. Now, we'll briefly test this, but I'll leave more extensive testing to you. At this point, what we want to do is we simply want to make sure that our mid rectangle seems to be working correctly. In other words, that we're triaging our switches. At this point, what we're going to do is a /p, and we're simply changing this then to the mid rectangle. And we want to go by function, sign, and we're still going to go from 0 to 1.57 as well as 1,001 data points. And you'll see here that we are somewhere in between our values. All right. Now, what we're going to do is we're going to need to continue to test these with higher and higher number of n to determine if this function is in fact converging. Once again, we're going to leave that for another video. We're actually going to see that we can wrap this entire process then into a while loop to determine whether or not these are converging. So you'll see some minor deviations in your area. In other words, it may jump a little bit, but ultimately they should be converging as you increase the n. All right, now for the last one, we want to go back to the Wikipedia article. And this time we want to take a look at the illustration of the trapezoidal rule. And you'll notice that effectively what we're doing here is we're leveraging two x values or two f of x values. And so essentially what we're doing now is we're averaging the height and then multiplying it by the delta x. So likewise with our formula here in our mid rectangle, which we can go ahead and copy and paste this into our trapezoidal. And let's go ahead and make the changes here. And I'm going to go ahead and take a second to copy, paste this here. And you'll notice that we also want to capture in the trapezoidal, we want to capture the n current, the xn left, and the xn right. We no longer want to capture our mid because technically we aren't using it. So what we want to do is we want to remove the mid, and instead what we want to do is we want to average the f of x's. So to do this, we take the f at x min, we want to add it to the f at x max, and we simply multiply the whole thing by 0.5 or divide by 2.0. So in this case, for my just decide I'm going to go ahead and multiply by 0.5. And then at this point, the only change then we really have to do is to our formula. We changed our documentation. So as I mentioned earlier, we simply multiply our 0.5 times our f of x min added to our f of x max, and make sure that your parentheses are matched. And you can see here that effectively what I'm doing is I'm getting the average f value, or the average y, or the average height, and I am multiplying it by the x delta. And once again, we don't have any changes to make in our results calculations. The only thing we need to do now is remove the extra %f and the reference to x mid, because we only have 4 output arguments for this particular file. And so you'll see here that we now match our 1, 2, 3, 4 output arguments for our trapezoidal.csv. And once again, a little cleanup here. I just noticed I did not delete the rectangle. So we have trapezoidal.csv, and I think we're set to go. So once again, we want to build it. And we want to see now that our trapezoidal function, or trapezoidal method, is now working. In this case, what we want to do is just simply replace mid-rectangle with trapezoidal in our parameter version of our executable. And you'll see that we have an area, we have a incorrect value here for the area. Let's see if we can figure out exactly what happened here. This one was pretty straightforward. If you notice, I inadvertently overwrote my return value here. So return results, and I think that's probably going to be about the only problem we've got here. All right, so let's go ahead and build it one more time. And let's rerun it. And you'll see now that in this particular case, the trapezoidal function actually appears to be the worst at estimating our area. Once again, I encourage you to look at your formula, increase the number of and play around with this and make sure that it's converging. The first thing that I want to do briefly here is I want to make sure that I do in fact have my parentheses matched. And also you want to go ahead and take a look and make sure that it matches the formula here that they've given you, particularly when you notice here that essentially this b minus a is essentially your delta x, and this is your f of x, or f of x left plus f of x right, divided by 2. So let's make sure that we have this, and we do not actually. So in this case, it's going to be our f of x left and our f of x right. We had a little typo in this particular case. We would have noticed that almost immediately if we had rerun this with a different n. All right, and while we're at it, let's go ahead and make sure that we don't have any mistakes in our earlier example. No, that one looks fine. And that one looks fine. Okay, so good. So this appears to just be a localized mistake here. Basically, at this point, let's make sure that we've got our documentation correct. Let's go ahead and recompile it one more time. And much better. Okay, so knew something was wrong. That seemed to be way too far off. The trapezoidal rule will work better for certain types of functions better than others, particularly anything that is linear. So that seemed like it was considerably off here. All right, so once again, hopefully you found this video useful. It also gave us a little bit of an opportunity to test our logic. as well as figure out what happened when we failed to return results. Notice we got the junk in our printf from main. So in addition to a little bit of math, we also got a little more practice at deducing what was wrong with our code logically. Notice that it compiled just fine, but there were errors actually in our logic. As always, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.